Hello dear students. Today we are going to have the continuation of the same chapter, matter and its composition. The topics covered in this video are Brownian motion, sublimation and law of conservation of mass. In 1827, the botanist Robert Brown was looking at pollen grains in water. He noticed that they constantly moved with a zigzag random motion. Brownian motion. The haphazard random motion of suspended particles on the surface of a liquid or air is called Brownian motion.
To determine the strength of attractive forces between the particles of different kinds of matter, take an iron nail, a piece of chalk and a rubber band. Try to break them by hammering, cutting or stretching. In which of the above three substances do you think the particles are held together with greater force? Since it is most difficult to break the iron nail, therefore, the particles of iron nail are held together by the strongest force, followed by the piece of chalk, while the particles of a rubber band are held by the weakest forces of attraction. Conclusion. The particles of matter attract each other. The strength of this force of attraction varies from one kind of matter to the other.
Sublimation. The process by which certain substances change directly from solid states to gaseous state on heating and vice versa on cooling is called sublimation. Examples are ammonium chloride, iodine, solid carbon dioxide, naphthalene, etc. Law of conservation of mass. Lavoisier proposed the law of conservation of mass. It states that matter can neither be created nor be destroyed. It can be converted from one form to another. It can also be stated as, in a chemical reaction, the total mass of the reactant is equal to the total mass of the products. That means there is no change in the mass during a chemical reaction. Experimental verification of the law of conservation of mass.
Take a clean conical flask fitted with a cork. Also take a small test tube. Then tie a thread to its neck so that it can be suspended in the flask. Weigh the flask, cork and tube together. Now take a small amount of barium chloride solution in the conical flask and a small amount of sodium sulfate solution in the test tube. Suspend the test tube in the flask with the thread. Weigh the complete system. Subtract the mass of the empty apparatus. The difference will give the mass of the reactants taken. When the thread is loosened, the two solutions mix together and a white precipitate appears in the flask. Barium chloride plus sodium sulfate will give us barium sulfate plus sodium chloride. Weigh the complete apparatus again along with the contents. Subtract the initial mass of the apparatus. The difference This will now give the total mass of the products, along with that of the reactant left unreacted, if any. We observe that mass comes out to be same as it was before the reaction. This proves the law of conservation of mass.
Homework: define Brownian motion, define sublimation, define the law of conservation of mass.